Scientists have brought together data from 14 genetic studies of the most common form of glaucoma, which is the leading cause of blindness. They've identified 3 areas of genetic code associated with an increased risk of developing the disease. The findings, published in the journal Nature Genetics, should help understand what causes glaucoma. Associate Professor Stuart McGregor is from Queensland's Institute of Medical Research, and he joins us now from Brisbane. Can you tell me firstly what prompted this particular strand of research?
Hi. So our research was to look at genetic factors for primary open-angle glaucoma, which is the leading irreversible cause of blindness. And so we are prompted because we want to understand the genetic basis of glaucoma so we can diagnose patients early, because the current treatments that we have are only effective if individuals are diagnosed early in the progression of the disease, so the disease can develop over time. And so genetic predictors are absolutely key to early diagnosis and effective treatment.
So you found 3 areas of genetic code, for want of a better phrase, which are associated with the disease. In layman's terms, what does that mean?
So these are distinct regions of the human genome which have variation in them, so that some people have a high-risk variant and some people have a low-risk variant. These particular new findings that we have individually have relatively small effect, but when combined with other genetic variants, help us build a more complete picture, if you will, of which people are going to be at high risk and which people are at low risk, and therefore which people who can be treated effectively using current treatments, which we believe will have a major impact on the devastating outcome of blindness affecting many Australians, and also on the healthcare costs.
So does it mean then that patients who have one or more of these genetic codes will in fact go on to develop the disease?
So these single variants are just susceptibility variants. So having one of these on their own isn't sufficient, but what we're planning to do in the near future is combine these newly discovered variants with a small set of existing variants and build a genetic predictor in the future, which will form an accredited genetic test, which will enable us to determine which individuals are at high risk.
You touched on the importance of early intervention there. What does this mean in terms of treatment?
So in terms of treatment, in the current time, we try and diagnose patients as early as possible, but that's difficult. So for example, there's about 300,000 Australians who currently have glaucoma. About half of those are undiagnosed, and so we're going to try and get a better predictor for those individuals, which means the current treatments, which generally speaking lower intraocular pressure, those treatments will work better if we can tailor them to the right people quickly. What else? The other thing which we would get is if we can get more insight into the biology of the disease by understanding these new specific genes, we can potentially develop new and more effective treatments in the future.
Dr. Stuart McGregor, good luck with that research, and thanks for joining us today.
Thank you.